What a jerk. Okay, here we go. Negative log of 1.95 times 10 to the negative 5 plus the log. How much base was there? We did it yesterday, right?
It was 0.53. I mean, 0.3.
Right? And that was what value? Okay. I heard a lot of these and then one other one, so. All right, 4.48. Okay, now, what would the pH be after the addition of, and I made it bigger, so here we go. So negative log of the same thing. And by the way, when you find this value right here, if you feel like just writing that value down there instead of that expression, there's nothing wrong with that. Plus, better not change colors, add to get after me. All right, this one I added base. So does base go up or down? Up. So it goes up how much? 0.02. So this becomes 0.32. And this becomes 0.48. All right, and what do we end up with? Okay. We all right with that? Okay. Then this one again, it's the same thing. Log of 1.95 times 10 to the negative 5 plus the log. This time I added acid. HBr is a strong acid. All right. So the base goes down 0.03. Is that right? And that's from this one, 0.27. And then this one goes up to 0.53. And we end up with, okay, do these make reasonable sense? Did the acid make it go lower? Yes. Did the base make it go higher? Yeah, so you're doing dandy there. Are you okay with this? Okay, because if we look real quick here, I made this little summary. There are three main problems on the test. One, finding the pH of a buffer and then solving for the pH after strong acid or strong base is added. That is what we just did. You okay with that? Those are this, not like super easy, but comparatively those are the easier ones. You okay with that? Okay, then the second type is what we did at the start of yesterday, which we'll say was probably a little harder.
I don't know if it may or may not part. You should just say that.
Where? Well, that's just too bad. I'm the official that you don't like right now. Okay? She's not even listening.
She wasn't even official. She was just trash.
Oh, so I'm just trash right now.
No, you're not trash. She was.
Okay. Speaking of trash, I think this portable microphone is not working very well anymore. If you've been watching my videos lately, it just stops for minutes at a time. And I do not know why, but I'll go order another one. All right. Okay, so here we go. Now, in this, there are three sub-things. Weak acid and conjugate base present, then use Henderson-Hasselbalch, because this one is a buffer, right? All right. Then, the other two are not buffers. If we do it and it only produces a weak acid, then we have to use Ka equals x squared over initial. All right? Then solve for x and negative log it. Okay? I do not have one where it's just excess conjugate base and you got to find Kb and do all that other math. We did one together, and you'll probably never see one again like that, but I do not have one on the test. Okay? And the test, it's all acids. Okay? So, like I shouldn't say that. You may, in this one, in the titration type problem, you might have excess hydroxide. But what I'm saying is I'm not going to have this end up being a weak base. Okay? So, then this, if you have excess H plus or OH minus, then you just find the concentration of the excess and negative log it. If OH minus is in excess, then make sure to subtract the answer. Sure. Yeah. don't actually. I'm going to start putting dots everywhere just to offend people, and they can work through it. All right. Then number 3 is KSP problem, correct? So there are 2 in a row right here. If you can do either of, or both of these, then you'll be fine. So we'll pause this for 7 or 8 minutes, give these a shot. And what I'm going to do is convert this to moles. 0.00741 grams over MgF2, so that's 3824, 62? 62 grams. What number does that equal? Point? Okay, 1 point what? Louder, someone over there?
0.00119.
Oh, yeah.
All right.
No, mine is 4.
What did you say, Pixel?
Oh.
All right. Now, is this my answer? No, homies. All right. Now, I got to come over here. I need to do something here. Whoops. I need concentration. I don't know what I'm doing right now. But this needs to be concentration, not just moles, right? So to get it to concentration, I got to divide it by 0.1. So we end up with 1.19 times 10 to the negative 3, or 0.0019. Whoops, 119. That's terrible. Olivia's going to complain any second. Nothing. There we go. Okay, now, what is that? All right, that's the concentration of the dissolved MgF2. Okay, now, we got to reason this through. KSP would be equal to Mg plus 2 and F minus squared, correct? All right. So, yes, it will be 4x cubed. I'll do it the long way also. So it would be 0.0012 times 0.0012, 2 times that squared. Why is it 2 times that? Okay, because this produced 1 mg, but for every 1 mg you got 2 F2s, so it has to be twice that value. And then you still have to square it. And this will tell you the KSP is anyone back that value up? All right, we got a lot. Okay. The most likely error from tests usually, which even when I wrote it, I forgot at first to put it in there, is sometimes you forget to multiply this piece by 2. But, as Hale said, if you just have it memorized, KSP equals 4x cubed. X is what we just solved for, which is 0.0012. Multiply it by 4, and then have that cubed. And it works the same way with less margin of error. Okay. You should cube, then multiply by 4, correct? I think it will definitely matter. All right. Are we okay? What's that? I don't remember, but it sounds like something that might have escaped from my lungs. Made my vocal cords vibrate. Okay, number 3. KSP is this. What is the concentration of that? Did you already do it? I have mostly yeses and some blonde hair shaking back and forth as a no. All right, well, how would you do this? 9.1 times 10 to the negative 6 equals, this is a 1-to-1, right? So it just equals x squared, or Ca plus 2 and SO4 minus 2 times each other. But since they break apart in a 1-to-1 ratio, they're the same value, so just square root. And my x was equal to by 003. Okay. So that's not awful, is it? Definitely not. You should put like a capital M, by the way. KSP will not have a unit, but if it asks for molarity, it has a unit. Okay. I'm reading some things. If you write the expression, it's KSP equals Ca plus 2 times SO4 minus 2. But since they break apart into a 1-to-1 ratio, these numbers are the same. And we don't know them, so we just say, all right, well, let's call them X. So KSP equals X times X, or just X squared. Good? Okay. Let me see any pairs. But what would you be looking for? Cannot. Cannot be. Okay, strong acid plus something else. Strong base or another strong acid. I don't think they would do that though. What else? There's other options. Alright. Just a plain weak acid, I guess. That would be okay. Anything else? Let's put this. A weak acid plus conjugate base of strong acid. That would just be a weak acid, right? If there was excess strong acid, then we would just have excess H plus. So even if I had HF, if I add NaCl, the Cl is not going to grab the H and affect the pH to make a buffer, because it is the conjugate base of a strong acid. Are you okay with that? It has to be a weak acid and then some sort of conjugate base that would either A, make a weak acid, or B, be the same as that weak acid. You okay with that? Those are your two main things that you should look for. It will be one of them. It's most likely that one. I did not even look at the options, so I don't know, but this one seems too kindergarten, so it's probably that one. Okay, what change will be caused by the addition of a small amount of HCl to a solution containing fluoride ions and hydrogen fluoride? So this is just a buffer question. We are adding strong acid, so it most likely says something about the pH decreasing. Probably. Which of the following could be added to a solution of sodium acetate to produce a buffer? Okay, this one's, I don't know. Like, I haven't looked at this for a year, so I don't know. But there's more than one. The easy answer is acetic acid. That's the easy one. But it's probably not that thing. All right, what else could? Strong acid, definitely, because the strong acid will react with the acetate to make the acetic acid and then leave some acetate. So yeah, like HCl, that would work. Not HF though, because it's weak. HNO3 would work. Any of my strong acids would work. Yeah, there's a lot that would work. It will most likely be that one. So those are your two options. It's most likely going to be one of these. Okay. A 25 milliliter sample of a solution of unknown compound is titrated with all these numbers that we don't give a crap about. The titration curve above was obtained. The unknown sample is. All we need to know about this is the shape of this. Does it look like this? No. So it's not strong acid and strong base. I will let you figure out what it is. Okay? You all right with that? A solution of HF is titrated with numbers I don't really care about again. Based on the table above, the best indicator for this reaction is blank. The Ka for hydrofluoric acid is this. There was one tiny little piece of note we said where we said the best indicator is the one where it's closest to the pKa. Does that sound familiar? Okay. So you take the pKa of that hydrofluoric acid and you find the one that is closest to that answer. Okay. Now, remember, Benson didn't love it because it wasn't super close, right? But remember, the range is plus or minus 1. So it's acceptable even though it didn't make her happy. I sensed. What? Okay. Well, no. It's going to say which one of them. So it's going to be methyl orange, methyl red, bromocresol purple, bromothionyl blue, thionyl blue, and phenolphthalein. It's going to ask you to pick which one of these works. And it's the one whose pKa here is closest to the pKa here. The molar solubility of blank is not affected by the pH of the solution. Okay, this one will be a little bit tricky. All right? pH will affect it if either the cation can form a weak base or the anion can form a weak acid. And go back to 17 minutes and re-listen to that over and over. What's that, Isaac? So the reason why is if the cation makes a weak base, so let's say it's like aluminum, and it's +3 up here, and it's in water, this will grab an OH minus, right? So if we have more and more, if the pH is different, more and more of this will grab more OH, and that will affect the solubility. Okay? But if it's strong and strong, it will have nothing to do with it. Okay? I know this one's the tricky one, but you can read it. It was in yesterday's lecture for just a couple minutes too. You can read about how pH affects the solubility. Well, that was some good English. All right. Of the substances below, blank will decrease the solubility of PbOH2 in a saturated solution. This question is not as complicated as the last one because of the options, if I remember. It's just the Chatelier's principle. Okay? So we're looking to make this dissolve less. We can put something in the solution that will basically force it to move to the left. Okay? So 6 is hard, 7 is medium. All the ones before, in my opinion, were easy. The common ion effect refers to the observation, and this is just the first unit, or first section in this whole chapter. So I would just read again. It's just, this is going to be the definition of what the common ion effect is. It's literally going to be bold in the first section of chapter 17, and it's going to say it. And it's going to talk about how having a common ion can decrease the solubility or yada, 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 yada. Okay? Okay, number 9. This is the same as number 6. So I will study this. All right? For which salt should the aqueous solubility be the most sensitive to the to pH? It's the one that has the cation or anion that can produce weak base or weak acids. Read that section. There's the 2 multiple choice from it out of 10, so that's 20% of the multiple choice comes from the section on pH. And then number 10, Why does fluoride treatment render teeth more resistant to decay? Like, what? We ain't never talked about that in this class, Davidson. Well, you're right. It's a nice, beautiful section in your textbook that explains why fluoride is so good for your teeth. So I would encourage you to read that and be able to answer such questions. Why am I doing this? Because it's reasonable for me to ask you to read 3 paragraphs out of a 1,000-page book. And don't look at me that way, Weber. You probably haven't read 3 paragraphs in the AP book for 3 months. Okay, so you can, I reserve the right to hold you accountable for stuff in the reading. Okay, questions besides why does fluoride